Next, we have breaking a vector down into the x and y components, example 1. This might be a little more challenging for some of us. This is kind of new. This is going to be 16 meters, and it's at 40 degrees, so that's my angle theta. If I look at that, I see, oh, that looks kind of like the hypotenuse of a right triangle, and in fact, that's what we're going to think of it as. So if we've got the hypotenuse and an angle, that's a good start. Now, remember, this is the x-axis and this is the y-axis. It doesn't really matter which one we start off with, but let's say we start off with the y-axis. Okay, so the y-axis, or the opposite, and if we've also got the resultant or the hypotenuse, that means we're going to use sine. Sine of theta is the opposite over the hypotenuse, or we can also think of it as just y over r, because it's sine. Opposite over hypotenuse is the SO part of SOHCAHTOA. Solving for y, all we need to do is bring the r up here. That's pretty easy. R times sine of theta equals y. Plugging in the actual values that I have, 16 meters times the sine 40 is equal to my y value. So I just type into my calculator 1/6. I don't even need to say times. I just say sine and then tap in 40. And that will give me my y value, which is equal to 10.28. 10.28 meters, or with just 3 sig figs, that would be 10.3 meters. Okay, so that is this value. Okay, then I have the x component, and I technically could use the y, or I could use the resultant, but because I just solved for the y, I don't want to use it, so I don't want to use the Pythagorean theorem. I'm going to go ahead and use the trig stuff, which is the x, or the adjacent, and the resultant, or the hypotenuse. That is going to be cosine. That's the ka part of SOHCAHTOA. So that's cosine equals the adjacent over the hypotenuse, or x divided by r. Okay, once again, bringing my r up here, because all I need to do is solve for the x. And I'll have x equals r times cosine theta. Now I can plug in my values just like before. 16 meters times the cosine of 40. That's equal to the x. And I tap into my calculator. This is something you definitely need your calculator for. Most people could not do this in their head. That would be 12.257, that's a 2, meters is the x, and with reasonable significant digits, that would be 12.3 meters. So my resultant here, or finally my answer here, 12.3 meters, and my value from here was 10.3 meters. Both of which are less than 16, so that's a good idea. And the fact that this angle is 40 would imply that the y-axis is approximately the same size as the x-axis, because remember, tangent of anything is just a ratio of the y over the x.